Hey there, my name is Dale Mudd, and I'm a graduate student here in the Astronomy Department at Ohio State University. I'm here to talk with you today about my recent paper with Speed and Mather, which focuses on looking for dual active galactic nuclei, or dual AGN for short, in the centers of emerging galaxies, in the X-rays, using the space telescope XMM-Newton. Hierarchical models propose there is a phase when substantial growth of galaxies occurs via multiple major mergers, where major here indicates that galaxies are of roughly equal mass. Now, provided the systems involved aren't overly gas-poor, these major mergers can be associated with starbursts, which are periods of star formation of 10, 100, or even 1,000 times that of our own Milky Way, as well as AGN activity.
Luminous infrared galaxies, or LIRGs, with IR luminosities above 10 to the 11th that of our own Sun, are often found to be mergers with distinctive morphologies. This high IR luminosity is due to heavy dust reprocessing. The dust in the systems absorbs much of the optical and UV photons and then re-emits them in the infrared portion of the electromagnetic spectrum as a black body. Because of the dust absorption, X-rays, which are less attenuated than other wavelengths, are a vital tool in diagnosing what is fueling the IR luminosity. The hard X-ray band, about 2 to 10 keV, of AGN output is typically best described by a power law of index 2 or larger, believed to originate from the inverse Compton upscattering of UV and optical photons from the accretion disk by energetic electrons in the hot corona. Starbursts also produce X-rays, and they come primarily from two sources. The first is a thermal plasma of about 0.1 to 1 keV from OMB stars and their supernovae. The second is a power law component associated with stellar companions to neutron stars and stellar mass black holes. High mass X-ray binaries tend to have power law indices of about 1 to 1.5, whereas low mass binaries tend to hover around 1.6. Values in the literature, however, may run as steep as 2. In our paper, we attempt to use the connection between AGN, starburst, mergers, and by extension, large IR luminosity, to search for systems undergoing interactions in which both supermassive black holes are simultaneously active. Only a handful of systems, such as NGC 6240, have shown definitive signs of such dual AGN. Finding the frequency of these dual AGN will let us know more about the merger process and, by extension, galaxy growth as a whole. We derived our sample from a subset of nearby, IR luminous, and interacting galaxies presented in Arribas et al. 2004. From their sample, we selected for systems with high IR luminosities and close optical nuclei, though we wanted them to be far enough apart that we believed they would be resolvable with the XMM-Newton satellite. In practice, this meant a rough projected nuclear separation of about 10 kiloparsecs. The most promising candidates from this search proved to be IRS 18329 plus 5950, IRS 19354 plus 4559, and IRS 20550 plus 1656. As our first step, we created images from the EPIC PN detector to see if two separate sources were seen in any of our systems. As you can see, things look promising for IRS 18329 plus 5950, as there were clearly two separate X-ray regions at the correct distances from one another. For our other two systems, however, only a single source is seen.
Next, we looked at the spectra of each system to try and see if we can disentangle what was the source of the observed X-rays, star formation or AGN.
Our fits all have a power law component with spectral index within the range of X-ray binaries. Our brighter systems also required a plasma component with parameters that were consistent with star formation regions. We then tried to fit our luminosities onto IR X-ray relationships for star formation. If our systems were overluminous in X-rays for the IR fluxes, it would suggest they have an additional X-ray source that is not stellar in nature, such as an AGN. If they are well fit by their relations, however, it would indicate that they are most likely dominated by star formation alone. First, we fitted the commonly used Rinaldi et al. 2003 predictions. As you can see in our figure, our systems are around the lower 1 sigma error bars. Comparing to other data, our galaxies have similar X-ray to IR luminosity ratios as H2 and composite systems, composite here meaning a hybrid AGN starburst. Noting that our systems are also more IR luminous than most systems used by Rinaldi et al. 2003 to calibrate their fit, we also used a fit done for more IR luminous systems done by Smionitis et al. 2011. Our systems seem to be more consistent with this relationship, which is more evidence for star formation domination.
In all of our tests, we do not find robust evidence for AGN activity in any of our sources, though our data cannot completely rule out AGN presence either. For more information, please see our paper which is posted in the archive in the link below. Thanks for watching!